Welcome back to the deep dive. Today, we're looking at a connection that might seem a bit surprising, how a math concept, one you probably ran into, connects directly to what happens out in a forest. We've got the source material called Differentiation and Erosion on Sloping Terrain,
Yeah,
and we're really zooming in on the part it highlights. Differentiation in forest technology, sensitivity of soil erosion to slope gradient.
exactly. And our mission really is to explore this specific source and show you how a tool like differentiation, something often studied, in college math, how it actually gives us real insight into something very physical, like soil washing away on a hillside.
Okay, let's unpack this then. So the source makes this explicit link, math differentiation and a practical forestry issue. What's the main idea here?
Well, look at that specific phrase again. Sensitivity of soil erosion to slope gradient. That phrase itself tells you where the math fits in.
Okay, sensitivity. And slope gradient, that's just how steep the ground is,
Right.
right?
Precisely how steep the slope is.
Hmm.
Now, think back to differentiation in math class. Fundamentally, what's it about?
Rates of change.
Rates of change, exactly. It's the mathematical tool we use to measure sensitivity. How much does one variable change when you tweak another one just a little bit? Like you press the gas pedal in your car, just slightly more differentiation helps us figure out precisely how much the speed changes in response.
Hmm.
It quantifies that relationship.
Ah, okay, so connecting that back.
Right. When the source talks about the sensitivity of soil erosion to slope gradient, it's literally saying we use differentiation to measure
Hmm.
how much more soil erosion happens
Hmm.
or how much faster it happens when that slope gets just a little bit steeper.
So it's not just observing, oh, steeper slopes erode more.
No, it's more precise. It's about finding the exact rate of that increase. How sensitive is erosion to that change in steepness?
Right, and here's where it gets really interesting. Because knowing that rate, that sensitivity number, that's not just theoretical math, is it?
Not at all.
That's incredibly practical for, say, forest managers or people planning land use.
Hmm.
If they know that even a small increase in slope on this particular soil type leads to a really big jump in erosion, well, that tells them exactly where they need to focus conservation efforts, doesn't it?
It absolutely does. That's the power here. This connection really shows why understanding these mathematical tools is so crucial. Differentiation gives us the specific language, the quantitative way to describe that critical relationship, that sensitivity between the physical slope and the erosion process.
So it moves beyond just a general observation.
Way beyond. It goes from slope matters to saying precisely how much it matters and under what conditions. It allows for prediction and targeted action.
Okay, so boiling this down based on the source material, what's the core takeaway? It seems to be that differentiation is the specific mathematical technique used within forest technology to measure exactly how sensitive soil erosion rates are to changes in slope steepness.
That's the essence of it for this specific application, yes. And, while this source focuses tightly on soil erosion and slopes, the underlying principle is much broader, using tools like differentiation to quantify sensitivity, to
Mhm.
figure out how much one factor influences another. That's fundamental in, well, countless fields. It's how we model and understand dynamic systems everywhere.
It really makes you think, though, this idea of sensitivity. Where else could measuring it, perhaps using these kinds of mathematical tools, be the key? The key to really understanding a complex system or figuring out how to solve a tricky real-world problem. That's maybe something for you to ponder after this deep dive. Thanks for joining us today.
Thank you.